Chapter 6.2, Conservation of Momentum. Quick reminder of the momentum and collisions overview. Chapter 6.2 will be covered on January 29th and January 30th. Chapter 6.3 will be covered on the 31st and February 2nd. We will have a couple of review days on February 3rd and February 4th, and the unit test will be on February 5th and 6th. A quick lesson outline. There will be a quiz at the very beginning of the period covering Chapter 6.2. We'll do some short notes on the law of conservation of momentum, and then the rest of the period will be spent working on the assigned questions from Practice 6D. Your homework assignment is to read Chapter 6.3, watch the 6.3 screencast, and start to work on the egg drop project. The learning targets are as follows. I can describe the interaction between two objects in terms of momentum of each object. I can compare the total momentum of two objects before and after they interact. I can state the law of conservation of momentum, and finally, I can solve problems using the law of conservation of momentum formulas. Billiard balls and impulse. What happens to the speed and or direction of the cue ball after impact? The cue ball is the white ball in the front. What happens to the red ball? What happens to the momentum of both, and how are they related? Momentum is conserved or maintained between billiard balls. The momentum lost of the cue ball equals to the momentum gained by the red ball. An example of this is Newton's cradle. The total amount of momentum in an isolated system is conserved. Conserved means that the momentum can be transferred from one object to another, but not lost to the system. A closed, isolated system, no other factors or forces play a significant role in the interaction. No momentum is passed to anything outside the system. The law of conservation of momentum states if a system is closed and isolated, momentum cannot be created or destroyed, only transferred. In a closed system, the vector sum of the momentum before and after an impact must be equal. So the mass and velocity of object 1 before plus the mass and velocity of object 2 before must be equal to the mass of the object and velocity of object 1 after plus the mass and velocity of object 2 after. The proof of the law of conservation of momentum is based on Newton's third law of motion. Whenever two objects collide or exert forces on each other from a distance, the forces involved are in an action-reaction pair, equal in strength, opposite in direction. This means the net force on the system, the two objects together, is zero, since these forces cancel out. For each object, force is equal to mass times acceleration, which is equal to mass times velocity, change in velocity over time, which is equal to mass times velocity divided by time, or impulse divided by time. Since the force applied and the contact time is the same for each mass, they each undergo the same change in momentum, but in opposite directions. The result is even though the momentum of the individual object changes, delta P for the system is zero. The momentum that one mass gains, the other loses. Hence, the momentum of the system before equals to the momentum of the system after. Is this roller coaster considered a closed system? Is it an isolated system? Sky Cycle is a pedal-powered roller coaster in Okayama, Japan, and it is not a closed system nor an isolated system. Quick reminder, read Chapter 6.3 and watch Chapter 6.3 screencast, and finally work on your egg drop project.